Good morning everyone, welcome back to your physics class once again. As you remember that in the last class we were actually learning the lens formula. We have seen sign convention, we have learned lens formula, we also have learned the magnification of a lens and power of a lens. Also we were solving some of the numericals, so let us continue and solve some more numericals from the chapter. So here I have taken one numerical, one question. So let us read what is given in the question, and according to that we will see. At what position a candle of length 3 cm? Last time we have discussed that what is the length, like if we are having a lens and this is our principal axis, so where we are putting the object, that is the length where it is placed in front of the lens, or the image is formed behind the lens, like that. And this is the position of the object or image. And if we say length 3 cm, that means whatever object we are using, what is the height of the object. So you need to understand, it is not placed at a distance. The object is saying, they are saying that the length of the image or object is. So let us see, at what position a candle of length 3 cm. So we are placing a candle and the length of that candle is 3 cm. It is not that it is placed at 3 cm. That will be the position. So but it is not given that it is a position. It is that wherever we are placing that candle is having a length of 3 cm, can be placed in front of a convex lens, and that's how we have taken a convex lens and we are placing a candle. Okay, this is the distance of the object from the lens. This is not given, but they have given the length of the candle. And you know, we have learned that the length or height of the object or height of the image, we take it as HO, because it is the height of the object and it is given as 3 cm. So they are asking where it can be placed in front of a convex lens, so that its image of length 6 cm. Now this candle is placed. Now it since the rays will pass through this convex lens and image will form, so they are asking where it can be placed so that the image of length 6 cm. So what is the height of the image or what is the length of the image is 6 cm. Can be obtained on a screen. So there will be a screen where we can obtain the image. Screen is something where we get the image, placed at a distance 30 cm. So this screen where we are getting the image, it is placed from the lens, it is placed at 30 cm, and here we will get the image. That means the image will be formed somewhere here. This is the position of the image, this is the position of the object, and then they are saying, okay, it is at the 30, it is formed at 30 cm. 30 cm behind the lens, and this is in front of lens. And we have learned in the sign convention, we have learned this, if we take it as origin, optical center if we take it as origin. So anything which comes to the left hand side, the distances will be taken negative, and right hand side all the distances will be taken positive. And since the image is formed on behind the lens or on the right hand side, the opposition of the image or distance, we will be taking it as 30 cm, and of course it is going to be positive. You understand, because it is falling on the right hand side. The lens also calculated, that is the second part. So by the way, we have to this V is there, and at what position a candle, that means we have to calculate where this candle is. That means what is this distance, let us say it is X, or you can call it as U, as we denote the position of object from the optical center. So this we have to calculate. I hope this is clear now. So to calculate, we have to use the formula. Okay, so the lens formula is 1 upon F equals 1 upon V minus 1 upon U. That means to calculate U, we need to have V, which is given, but we don't know F first. So to calculate U, actually we are going to use this information. This is the height of the object and height of the image. We know we can calculate using this too. We know magnification is height of the image or length of the image upon length of the object. Length of the image is given as 6 and length of the object is 3. Then this M is coming 2. First thing. Second thing, since it is a convex lens and the image is formed on the right hand side, that means image is formed behind the lens, and since it will be formed behind the lens, the image will be real. and if the image is real, the magnification will always be negative. This we have learned and we have seen also. When the image is formed real or it will be formed inverted, the magnification will be negative. If the image is virtual or it will be upright, the magnification will be taken positive. Okay, so here m is coming minus 2. So to calculate the relation, we also know that m is v upon u equals minus 2, isn't it? Now v equals, this will be minus 2u, correct? Now the value of v in terms of u is coming minus 2u. Also we have seen just now that the v was given as 30 centimeter. In the formula we have seen that the distance of image from the optical center was given as 30 centimeter. So that means this v we can write as 30 centimeter. So it is 30 minus 2u. If you cancel, this will give you u equals minus 15 centimeter. That means what is the position of object coming? It is coming 15 centimeter. This minus is telling you that it will be on the left hand side. That means here is the object. So the object is on, of course it is minus, that means the object is placed in front of the lens. This is how we say, in front of the lens. And also you can see that since it is on the left hand side, so this distance which is 15 centimeter will be taken as negative, and that's why it is coming negative, and the image was formed at 30 centimeter. I hope it is clear. So now with u minus 15 and v 30, let us calculate the focal length. This length formula we are going to use. U is minus 15. Okay. Now 1 upon f equals 1 upon v, 1 upon 30, because v is 30, then minus 1 upon u. U is coming minus 15. So we will be writing it with sign like this. So 1 upon 30, this minus and this minus will become plus 1 upon 15. So if we take LCM, that would be 30. Now if you take the LCM, it will give you 1 plus 2, which is 3 by 30, 1 upon f, or it will be 1 upon 10. And when you reciprocate both sides, it will give you f equals to 10 centimeter. This is your focal length of a convex lens. Here in this formula you see what are the things to remember. That if it is saying that an object is formed or object is placed in front of the mirror, that means it is on the left hand side, we always say, and that distance, since it is on the left hand side, that distance will be taken in with negative sign. And if the image or anything is formed or is taken on behind the lens, that means on the right hand side, so the distance will be taken positive. As we have learned, it is similar to the sign convention. Left hand minus x-axis, right hand plus x-axis. Above this origin plus y-axis positive, below the origin minus y-axis will be taken as negative. Also for a real image, magnification will always be taken in negative, and for a virtual image, magnification will be taken as positive. So these are all the things, and here f is coming 10 centimeter, that means f is positive. You need to remember all these things, that for a convex lens, focal length will always be positive, whereas for a concave lens, the focal length will always be negative. In fact, you can remember it in like for a concave lens, concave means this lens, f, u and v. F means focal length, u is the position of the object, v is the position of image. They all are in negative sign, or they all are negative, whereas in a convex lens, focal length is always positive. U is negative in both the cases, whether you take convex lens or concave lens. And also you have learned that convex lens will be or will form real images as well as virtual images. If the real image is formed, it will always be formed behind the lens, that means always on the right hand side. So the distance will always be taken as positive, that is v. If it is virtual, that means it will be formed in front of the mirror, that means this side. And if the image is formed on the left hand side, it will always be taken as negative. You need to keep this in your mind. Okay, now let's see the next question. Okay, here we have our next question. Let us read the question and see. An illuminated object lies at a distance 1 meter from a screen. So there is an object placed at 1 meter distance. Whether you write 1 meter or we can take it as 100 centimeter from the screen. So screen is something where we get the image. That means this is where we get the image, on screen. So this is the position where we get image, and this is our object. They are 100 centimeter or 1 meter apart. A convex lens is used to form the image. So we are using a convex lens here to form the image of the object on a screen placed at a distance 75 centimeter from the lens. Okay, so we are here taking a convex lens which is used to form the image of this object on a screen placed at a distance. So this screen is placed at a distance of 75 centimeter from the this lens. So this distance is 75 centimeter. If this total is 100, this is 75, so of course this distance will be 25 centimeter. Correct? Now we have to calculate the focal length of the lens and also the magnification. Now here you see this is our object, and the distance of object from the optical center or from the lens is taken as u, and the distance of the lens from the image or the image from the lens is taken as v. Now first let us decide the sign, since we have to calculate the focal length. Okay, here if you see the lens is there and the image is placed on the left hand side. We have seen that if it falls on the left hand side, the sign will be taken as negative. So u is given as 25 centimeter, but we will take the minus sign. Image formation is on the right hand side, or you can say the object is placed in front of the lens and the image is formed behind the lens. So it is on the right hand side, so we will write v equals 75 centimeter, and it will be plus as it is on the right hand side. And now we have to calculate f. To calculate this, it is simple that we are going to use the lens formula. And one more thing which I want you all to see, that image is formed on the right hand side. So if you can recall all the cases which we have learned in convex lens, all 6 cases, where in 5 cases we were getting the real image, if you remember, and the images were formed on the right hand side. Every time they were real and they were inverted. That means this time, since the image is formed on the right hand side, it is going to be real image. Correct? And if the image is formed on the left hand side, it will be virtual, it will be upright, and it will be magnified. So you remember, since the image is formed on the right hand side, it is going to be real, because we are going to use in the second part. Now to calculate f, we will use the lens formula, which is 1 upon f equals 1 upon v minus 1 upon u. Whenever we put the values, we always put the values with sign. So whenever we are going to apply the formula, we need to take the sign or assume the sign. Now 1 upon v is 75 minus 1 upon u is minus 25. We will write the values with sign. So it will be 1 upon 75, minus and minus will be plus, 1 upon 25, 1 upon f. If you take the LCM, it will be 75 upon 75, 1 into 1, and this will be 3. So eventually it will be 1 upon f, 4 upon 75. When you reciprocate, since it is 1 upon f, so when you reciprocate, it will be f, and this will be 75 upon 4. F equals 18.75 centimeter. So your focal length is coming 18.75 centimeter. Also you see the sign of the focal length is coming plus. Plus is the focal length, or for a convex lens, the sign of the focal length is always plus. You need to remember this. The focal length of a concave lens is taken negative. Likewise, u, that is the position of object, in both the lenses will always be taken in negative sign, since the object will always be placed on the left hand side. And likewise, if the image is real, that means on the right hand side it will be taken, the distance will be taken positive. If the image is virtual, that means on the left hand side, it will always be taken as negative, since it is on the left hand side. You need to see this. Once you see this, you clear it out, it will be clear. Okay, now since we have calculated f, now let us calculate our magnification, that is m equals v upon u. Now what is our v? It is 75. What is our u? Which is minus 25. So m, if you simplify 25, 3 is a 75 with minus sign, minus 3. Since it is coming minus 3 and we have learned the magnification will be negative if the image form is real, and here we have seen that the image formation was on the right hand side, that means the image form will be real, which is correct. So this is our question. Now let's see one more question. Here I have taken another question. A lens forms the image of an object placed at a distance 15 centimeter from it. So there is a lens. Let me show you. Just now we don't know which lens we are using because it is not given. So I am just using this sign that this is our lens. The lens forms the image of an object placed at a distance 15 centimeter from it. So object, let us say that this is the principal axis. Somewhere here an object is placed at a distance of 15 centimeter in front of it. That means in front of it. At a distance, now there is another statement that at a distance 60 centimeter in front of it. This lens which we are using is forming the image of this object which is placed at a distance 15 centimeter. The image is formed at 60 centimeter. You need to read the question and understand. A lens forms the image of an object placed at a distance 15 centimeter. So the object is placed at 15 centimeter from it. The image is formed at a distance 60 centimeter. So somewhere here in front of it. So the object is also placed in front of it. The image is also formed in front of it somewhere here. But the distance of the image is 16 centimeter. I think it is clear. I have repeated myself so many times, by the way. In front of it, find focal length. You have to find the magnification, also nature of image. Okay. So here if you see, this is our object. So this distance will be u, as we know that the distance of object from the lens is always taken or denoted by u. And since it is on the left hand side, the distance will be with minus sign. This we have already learned in sign convention. We have seen. So let us write the given information. So what are the informations given? It is that u will be 15, of course with minus sign as it is on the left hand side. Also the position of image is given at 60 centimeter, and this time the image is formed in front of the mirror, in front of the lens, and that means left hand side. So it will also be taken with negative sign. You have to calculate f. Okay. To calculate this f, we will be using the very lens formula which we have learned, which is 1 upon f equals 1 upon v minus 1 upon u. Correct? 1 upon f equals 1 upon v is minus 60 minus 1 upon u. U is minus 15 here. So it is minus 1 upon 60. Minus and minus will become plus 1 upon 15. When you take LCM, 60 will be your LCM. 60 and 60 will get cancelled. This will be minus 1 and then this will be plus 4. Correct? Here if you see, this is 1 upon f over 4 minus 1 will be 3 upon 60. When you reciprocate, f will be equals to 60 over 3, or f will be equals to 20 centimeter. Now see, f is coming 20 centimeter. F is coming, f is positive or f is coming with plus sign. That means this will be a convex lens. As we have learned that focal length of a convex lens will always be positive. Focal length of a concave lens will always be negative. It is the lens is convex. Now you have to recall all the 6 cases. Among all the 6 cases, we have 5 cases where we get the real images, and one last case was the case when we get the virtual image. Okay. So next part of the question was we have to calculate focal length. We have calculated already, and also we have to calculate the magnification. Magnification will be v upon u. What is our v? It is minus 60. What is our u? It is minus 15. So when you simplify, it will come 4. In fact, plus 4. So magnification is coming plus 4. If magnification is +4, that means you know that the image will be virtual. We have learned this also, that when the image is real, magnification will be negative. If magnification is positive, that the image will be virtual. Now let us see that just now we have seen that the image formation is also on the left hand side, and if you can recall the cases where we have learned all the 6 cases for a convex lens, it is the last case where we were getting the image on the left hand side and the image was virtual, it was erect and it was magnified, remember? So that's how you can also write in the third part that was asked what is the nature of the image. So image will be magnified, it will be virtual and it will be upright. It is the case, the last case in the convex lens, the formation of images we have seen that where we are placing object at different positions and we were getting the image at different positions. So you can always remember. So one more question I guess I'll take. Okay, so here I have taken another question. The magnification by a lens is 0.5 plus 0.5. That means the magnification is given plus 0.5. Name the lens and state. First you have to name the lens. See here we have learned that the magnification of a convex lens, since convex lens form a real image as well as virtual image. If it is forming real image and inverted image, the magnification will be negative. If it will form virtual image, which is only one case, then the magnification will be taken as positive. But then it can have both the cases. Whereas if you take concave lens, it will always for virtual image, that means magnification will always be positive. So here we will, the magnification they have given is positive, because for a convex lens it could be plus or minus both, but in concave lens it will always be plus. And now name the lens. We have named the lens already, and then state how are u and v. U is position of object and position of image related. Since m is 0.5 simply, so we know m is v upon u, which is equals to 0.5. So v will be equals to 0.5 u. Okay, that means the position of the image will be 0.5 times of the position of the object, and that's how we simplify the questions. And there are more questions given in your question exercise. You can solve some of the questions. Also try to solve the ray diagrams, so that once you draw the ray diagrams, you will get to know how to draw the ray diagrams. Also you will get to know that where are the position of the objects or where are the position of the image. That would be more clear to you all. Keep practicing, keep solving numericals, and please be very clear with the sign of the focal length or the position of the object, position of the image. These are all things. The sign of the magnification. The more you will read, the more you will get to know. And then we will meet in our next class, which is tomorrow. And tomorrow we will be seeing the magnifying glass, and then the application of lenses. And then after we will start our new chapter.